Welcome to Pre-Calculus Trig, Part 2 of our lecture on the law of sines. So example 6 says find the height h of the shaded triangle. So that means this h side is perpendicular to the base here. So that's a 90-degree angle. So these are my given dimensions, and I wrote them on here so we could see where they are. All right, so I'm going to go ahead and I'm going to figure out a strategy for solving this triangle here for h. So what I see that this piece right here, this one side, is the hypotenuse of this big right triangle here that contains h as one of its sides. All right, so I know this angle is 35, this angle is 51, so I can find this angle because this is a straight line, 180-degree angle. So let's just go ahead and do that first. So 180 minus 51 is equal to 129. So this angle is 129. All right, so that means I can figure out this angle here in the skinny triangle, because 35 plus 129 plus whatever that angle is has to equal 180. So I have 180 minus 35 minus 129 is equal to that angle up there, which is this one here, 16 degrees. So on this pink outline triangle, I can use the law of sines to find that hypotenuse side that I'm looking for. So let me call that x. So I'm looking for that hypotenuse x. All right, so I can say, since I know this side right here, I can set up the law of sines because I have 16, the angle opposite this side, which is 1500. So I can say sine of 16 over 1500 is equal to sine of, let's see what's across from x. Here's x. The angle across from x is 129. So sine of 129 over x. So cross multiplying and dividing, I have 15 sine 129, 1500 sine 129 divided by the sine of 16. All right, so if I type that in the calculator, I get 4229.176. All right, so that's my side x. So now I can do right triangle trig because I've got this angle, I've got the hypotenuse, and I can figure out h because the sine of 35 is equal to h over x. Sine of 35 is equal to h over x, 4229.176. So h times 1 is h is equal to 4229.176 sine of 35. So typing that in, I get that the h is 2425.76. That's this dimension here. All right, so I use law of sines on this triangle to find x, and then I used right triangle trig on this right triangle to find h. Next example says find the perpendicular distance between the parallel lines. So these blue lines are the parallel lines. So the perpendicular distance would be, let's put it inside the triangles here, would be this distance h here that we're going to be looking for. So we're given some information. We're told that angle BAC is 75. BAC is 75. So 75 for this angle. Then ABC, This is ABC, so this angle here is 27. And then we're told that AB is 185. So this whole side over here is 185 feet. So in a problem like this, we can utilize the law of sines on the oblique triangle. We have this side over here. We can calculate this side, this angle here, because we know two angles in the triangle. Let's go ahead and do that first. So that angle ACB is 180 minus 75 minus 27. So that's 78. So this angle here is 78. All right, so I have enough information to set up a law of sines problem, so I can start by saying sine of 78 over 185. All right, and that's because I have this side opposite this angle for this oblique triangle. All right, if I'm going to find h, I can use right triangle trig on this if I knew this right triangle here, if I knew this hypotenuse. Or I could also use this one here as well if I knew this hypotenuse. So you could choose either one. So let's just say we're going to use this triangle, this right triangle here, and we're going to figure out this part of it, this side of the triangle, using law of sines. So I'm going to say sine of 78 over 185, that's this. And if I want this side here, AC, that's AC, then that side is across from this angle here. So I would say sine of 27. Let's just call it side AC. All right, so I can cross multiply and divide. So I can say AC is equal to 185 sine of 27 divided by sine of 78. So I typed this into my calculator and I got 85.865 feet. So that's this side over here, 85.865. All right, so now let me just highlight the triangle a minute. So that green triangle there, I could say that the sine of 75 is equal to opposite over hypotenuse. So my equation is right here, sine of 75. So opposite 75, that's h, divided by hypotenuse, that's this side here. So I can say h times 1 is h, is equal to 85.865 sine of 75. And I type that into the calculator, and I get 82.939 feet. So that's this distance h between the parallel lines. So a lot of times you see these kinds of problems like this, with this kind of setup to find the distance across a river, distance across a moat, some type of application problem. But what I'm doing here in this video is I'm giving you some general diagrams that come up a lot in word problems having to do with the law of sines, with a different story attached to it, but the basic diagram will be applicable to many different story problems. So example 8 is a similar setup. So we've got two parallel lines, and we've got a triangle, a general or an oblique triangle inside the two parallel lines. So we're asked to find the lengths L and M and the distance between the parallel lines. So that's going to be our H, perpendicular distance here. All right, the information is given this way. The angle of depression from B to A is 36 degrees. So if I'm at B and here's the horizontal through B, I'm looking down and I'm rotating through 36 degrees while I'm looking at A. So that means this here is 36 degrees, angle of depression. And then we're told that the angle of depression from B to C, so at B, looking down to C, I'm going to rotate through this amount here, and we're told that's 20 degrees. All right, and we're also told that the distance AC is 6.8 miles. So AC is 6.8 miles. All right, so now what I need to do is I need to figure out what this angle is here opposite my side, so I can use law of sines to find L or M. So I can say sine of whatever this is divided by 6.8 is equal to the sine of whatever this is. Well, anyway, let's figure some of this out first. Let's figure out this angle first. All right, so that angle is going to be 180, the straight line angle here, minus 36 minus 20. So 180 minus 36 minus 20. I type that in and I get 124 degrees. So this is 124 degrees here. Now I've got that angle, so I can start setting up my law of sines. I could say sine of 6.8, sine of 124 over 6.8 is equal to, all right, so we need another angle here. Let's see, so I've got parallel lines cut by a transversal, so this is 36, so this is 36. Alternate interior angles are congruent. All right, and I've got that set up over here as well. Parallel lines cut by a transversal, alternate interior angles are congruent. So that's familiar from geometry. All right, so I've got some angles there. So I can set up law of sines for either L or M. So let's do L first. So the sine of 124 over this side, 6.8, is equal to the sine of 20 over its opposite side, L. All right, so L is equal to 6.8 sine of 20 divided by sine of 124. Cross multiply and divide. So type that into the calculator, and I get 2.805 miles. All right, so we can set up a similar calculation for M. So we've got the sine of 124 over 6.8 is equal to the sine of 36 over M. All right, and now I can cross multiply and divide. M is equal to 6.8 sine 36 divided by the sine of 124. If I type that in, I get 4.821 miles. Okay, so that's L, that's M. Now we're asked to find H as well. So we can look at the right triangle now. So here's your H. So let's just choose this one. We could say the sine of 20 is opposite over hypotenuse. So sine of 20 is equal to H over M, which is 4.821. So H is equal to 4.821 sine of 20. So typing that into the calculator, I get 1.649 miles. And these numbers could be rounded if necessary, but I just left them 3 digits to the right. All right. So here's another very common problem you'll see for the law of sines. It says find the distance across the pond. So here's the pond. Here's the distance across the pond. That would be BC. And you could be given various pieces of information. So in this problem, it said reference point A, here's A, is 1,200 feet from C. So this side here is 1,200 feet. And then we're also told that it's 1,320 feet from B. So this side over here. So we have two side lengths. And then angle ABC is 35 degrees. ABC. So we're given some information here, 3 pieces of information. So whenever we have 3, we should be able to solve triangle. All right, so we're trying to find this side over here, BC. So with the given information we have, we can set up law of sines using these two. So let's write that down. Sine of 35 degrees divided by 1,200. And then we have another side, 1,320, which is opposite angle C right here. Sine of C, we don't know C. All right, but we can figure out what the sine of C is and then do an inverse sine to get C. So we can say sine of C is equal to cross multiply 1,320 sine of 35 divided by 1,200. So I got 0.6309341. So taking the inverse sine of that, I should have C. So I got angle C is 39.1191 degrees by taking the inverse sine. So over here I have 39.1191 degrees. Alright, so now I can figure out angle A, which is 180 minus 35 minus 39.1191. So angle A is 105.8809. I typed it into the calculator. Alright, so that's angle A. Alright, so my diagram is clearly not to scale, but it doesn't really matter. In geometry, you just assume that your diagrams reflect the numbers you're given, not necessarily the scale. Okay, so we've got that. Now we can figure out side BC because we've got that angle opposite side BC. So we can say the sine of 35, we're going to reuse the same ratio, over 1,200 is equal to the sine of 105.8809 divided by its opposite side, which is our side BC that we're looking for. So now we'll just write out our final step here. BC is equal to cross multiply and divide 1200 sine of that angle divided by the sine of 35. So if I type that into the calculator now, my final answer is BC is equal to 2012.285 feet. So I'm just going to keep those digits to the right of the decimal point, but it could be rounded if asked. So a word of caution about any kind of rounding you do within a trig problem. Alright, so up here you want to keep this many digits when you're working with a sine and an inverse sine. Alright, you want to keep 4 or 5 digits with any internal calculation, like these numbers here. Alright, because anytime you put that number further into more and more and more calculations, you embed a lot of rounding error within a problem. So carry through all 4 or 5 digits all the way through your problem. No rounding closer than that until you get to your very last number, and then you decide whether your problem statement asks you to round. Otherwise, keep all of those digits 3 or 4 or 5 digits to the right. Never round to the tenths or the hundredths place within a problem. All right, here's the last problem I'm going to do. So sometimes you'll see a problem, a strange looking, just a mishmash of various triangles, like you might see something like this. I'm asked to find side L here. So I've got 2 oblique triangles here, and this slope right here is shared by both of these 2 triangles. All right, so I'm given these angles right here. This angle is 48 degrees. This angle is 15 degrees. And the dimension between this point and this point is 145 feet. All right, so I'm calling this A, C, B, these 3 points on the purple triangle, and I'm looking for this side L. All right, so I got to come up with a strategy. So I can see that this side L is part of this oblique triangle here. All right, and I know that I have one full side of that oblique triangle and one angle here. So since this side here is part of the purple triangle, this oblique triangle, if I could find some more information about these angles in here, I could set up the law of sines. All right, so what I'm going to do is I'm going to use this angle right here, and that's with the ground. So let's raise up the ground level to here and recognize that this angle here is also 48 degrees. All right, because it's parallel to the ground. All right, so if that angle is 48 degrees, let's just drop a line. We're drawing some what we call auxiliary lines in geometry to help us figure things out. So if I make that a right angle there, then I could figure out this angle up here. All right, and the way that I can do that is to see that 15 plus 48 will give me that angle right there. So 15 plus 48 is going to give me that angle right there, 63 degrees. All right, so if that's 63 degrees, then I should be able to figure out this one as well. All right, because this angle 63 plus this angle plus 90 degrees is equal to 180. All right, so 63, let's just say 180 minus 90 minus 63 is going to give you that angle. So I type it in and I get 27 degrees. All right, so this angle right here is 27 degrees. All right, so now I have enough information on that purple triangle in order to set up the law of sines. So I'm going to say sine of 27 over its opposite side. So that's this one here, 145. So I'm inside this purple triangle now. 27 is opposite 145. All right, and I want to figure out the angle opposite the side L, and I'm going to put that there. So here's L, so I need this angle right here. All right, so that angle, if I look at only the purple triangle, 15 plus 27 plus that angle's got to add up to 180. So let's just do that over here. 180 minus 27 minus 15. All right, so that angle is, in my calculator, 138 degrees. This one's 138 degrees. So I need that one. Sine of 138 over L. All right, so this is opposite L. And then here, this 145 is opposite 27. All right, so cross multiply and divide. L is equal to 145 sine of 138 divided by the sine of 27. So typing that into the calculator, I get L is 213.714 feet. All right, so I might add with a problem like this is just one strategy to figuring this out. There are other strategies that you could come up with for figuring this out that might be equally as valid. All right, so this is another example of a law of sines problem. So that ends the examples that we're going to do here for our word problems, for our application problems. And like I said, these are just models of other stories that might go along with the problem that the setup basically would look the same. So these strategies are going to apply to multiple word problems.